One of the things that I've explained multiple times throughout this course is that the database server, when it receives a SQL injection payload from the web app, simply doesn't know that it's SQL injection. And that all comes down to the web app formulating a SQL statement that combines both the query and the untrusted data from the user, such that you can't tell where one ends and the other one begins. So remember, if we have a look down here at the code, down at line 15, where this SQL statement is actually prepared, by the time we get past there, down to line 17 where it's actually executed, even the web app doesn't know what's what. And I want to show you what the database is seeing when we run this query. So what I've done is I've got SQL Server Profiler running on my machine, and that's going to have a look at what the database is seeing. So we're going to jump back over to the web app, reload this page, and now here's SQL Server Profiler. Now there's been a couple of database queries run. I've got the top one selected, and down in the bottom section of the screen we can see the query. Select supercar ID model from supercar where cylinders equals V12. Now let's go to the web app and mount one of our attacks. And we'll just use that simple tautology from before, or 1 equals 1, and then comment out. Let's run that. Jump back over to SQL Profiler. The query is this one just here. Now look at the bottom section where the code actually shows what's been run. You can see what SQL Server is seeing. It's just one clean statement that looks perfectly legitimate. It doesn't know that that single quote after V12 was injected by us. Now the answer to this is really the crux of the answer to all of SQL injection, which is that queries must be parameterized so that the data never actually mixes in with the query itself and changes the logic of it. Let me show you what I mean by that. I'll jump back to Visual Studio, and on my clipboard I have a replacement for lines 15 and 17. Let me paste that in now and you'll see how this changes. So here's what we're seeing. Two things. In the query itself, where we used to just be appending that cylinders string directly into the query, we can now see cylinders equal, and then there's an @ sign P0. And this means parameter 0, the first parameter. We can also see that this is now constant, so it can't actually be changed at runtime. This is hard-coded. This will always be the query. What we're seeing then on line 18, when I actually execute the query using the SQL query method, I'm passing both the query itself and the cylinders from the parameter. And what this method signature actually means is that we're going to have those cylinders passed as a separate parameter to the query. I'll show you what I mean. Let's recompile the application. We'll jump back over to the web app. Now note also we've got every car on the web app at the moment. Let's reload the page. Now the first thing you'll see here with the page reloaded is that there are no cars whatsoever. Let's jump over to SQL Profiler and see what query the database actually saw. So the query that we're after will be this one just here. Now have a look at the statement down the bottom of the screen. This looks quite fundamentally different to the earlier one up here. So see, this looks like just one simple SQL string. The new one down here, the parameterized one, actually passes V12 as P0. So in fact, if you have a look at this segment of the query, this is what we had hard-coded into the app with the update I just pasted in. You can see the @P0 there at the end of the highlighted section. And then you see as a separate parameter in this sp_execute SQL command, P0 is declared as an nvarchar 13, and then the value of it is actually our SQL injection attack. So it's V12 and the quote and everything after it. And in fact, you can see that even the quote has been escaped. We've got two quotes after V12. So effectively what this all means is SQL Server is now doing what it really should do, is that it's taking the entire parameter, so the actual SQL injection attack, and it's looking for supercars with cylinders that match that. Which of course they won't, because we don't have any cylinder layouts that are a legitimate SQL injection attack. So this is critical. This is the heart of the fix for SQL injection. SQL command parametrization. Get this right and injection simply stops. You simply cannot break out of the data context and into the query context. Now this isn't the only way of doing this though. Let's move on and take a quick look at how we do this with a stored procedure.